Acceleration due to gravity is equal in magnitude to the force exerted by the earth on the body of unit mass. So they are saying acceleration due to gravity is nothing but force. So we know acceleration is F by m, and if m is 1, that is if it is unit mass, then acceleration will be equals to force. What is that force? It is the force exerted by the earth on that body. Okay, what is the unit of acceleration? It is generally meter per second square, or from this we can write Newton by kilogram. So Newton per kilogram. So that is what is said. Expression of acceleration due to gravity, g in terms of capital G, that is universal gravitational constant. Suppose the mass m, small m, is situated on the surface of the earth or at a small height, then force of attraction on the m due to earth. So that is given by g m by r square. So we are here, there are two masses we are considering. One is the mass of earth, that is me, and another one is the mass small m we have considered. So gmm by r square, and because of acceleration due to gravity there will be a force, that is mg. This we know. And yes, now we are going to equate these two equations. So mg equals to g me m by re square, where r is the radius of earth. So from this we are getting m and m goes, so g equals to gm by r square, capital G, mass of the earth, by r square. So this is the relation, and this is also the expression of acceleration due to gravity in terms of capital G. Okay, now let us see how we are calculating mass of earth and density of earth. So from this g equals to gm by r square, we are writing m equals to g into r square by g, capital G. So where m is the mass of earth. So we are going to find mass of the earth now. So what is the g value of g? This is 9.8 meter per second square. The radius of earth is found to be 6.37 into 10 power 6 meters. And capital G, gravitational constant's value is 6.67 into 10 power minus 11 meter cube, kilogram power minus 1 second square. So we are substituting these things in this expression, and we are getting mass of the earth as 6 into 10 power 24 kilograms. So this is the value of mass of the earth. Now we know mass is equals to density into volume. So instead of volume we are writing 4 by 3 pi r cube, and instead of density, yes, we are writing density. Now 4 by 3 pi r cube into rho, that is mass of the earth, this is equals to g r square by g. So we are equating this to this one. Okay, 4 by 3 pi r cube rho that is equals to g r square by g, because both are the expressions for mass of the earth only. So now we are equating these two equations. Now rho equals to this 3 we are taking there, 3g, and this r square and r cube. R square is going and one r is left, so that is here, pi 4, and g is already there. So on substituting the value of g, that is 9.8 meters per second square, and pi 3.14, and radius of earth 6.37 into 10 power 6 meter, and gravitational constant's value, we get density of earth equals to 5.5 into 10 power 3 kilogram per meter cube. So this is what is you have to remember how is related to density and mass, so that we have to remember. Variation in the value of acceleration due to gravity, effect of altitude. So we are going to see how the value of acceleration due to gravity is going to change with the altitude, with the height. Okay, so first, so this we have already seen why we are equating these two things, mg because of acceleration due to gravity, and because of attraction forces between m and small m and earth. So this is the force, and this is the force due to acceleration due to gravity. So we are equating these two things, that is mg equals to gme m by r square. So m is nothing but the small mass on the surface of the earth. Now I am writing the same equation if the mass m is at certain height above the surface of the earth. Okay, so above the surface of the earth I am keeping that mass at certain height. Okay, now we are going to see how the equation changes, m into g dash. So at that time the value of g will be changing, acceleration due to gravity changes, g m by what is the distance we have to take? We have to take RE plus H. Okay, we have to take the distance from the center of the earth to the mass M. So that is H plus RE. So that is what we have taken, RE plus H square. So now we are just dividing the above two expressions what I have shown. So G by G dash is equals to R plus H square by R square. Okay, now we are writing this in this format. Okay, R plus H whole square by R square, that will be equals to 1 plus H by R whole square by 1. So now G by G dash is equals to 1 plus H by R whole square. Now from these two I am writing this one, G dash is equals to G by 1 plus H by R whole square. Okay, so this is the value of gravity at certain height. Now that is acceleration due to gravity. As we go above the earth's surface, acceleration due to gravity goes on decreasing. So let us see, but we have to remember this point and let us see in some cases also. Now if H equals to R, that is 6,400 kilometer, if our body is kept at a height which is equals to the radius of the earth, that is 6,400 kilometer, then what will be the value of G dash? Let us see, G dash is equals to G by 1 plus H by R whole square, we know that, and instead of H I am writing R only. So 1 plus R by R whole square, that is 1 plus 1 plus 1 whole square, so that is equals to G by 4. So at the height equals to the radius of the earth, the value of gravity will be equals to, acceleration due to gravity will be equals to G by 4. Okay, now if height is negligible in comparison to the RE, then using binomial theorem. So if the height is very small when compared to the radius of the earth, then only we have to use this. Okay, if the height is very small compared to the radius, then only we have to use. So G dash is equals to G by 1 plus H by R whole square. So using binomial theorem, I am going to use binomial theorem. Before that, let us take this to the numerator, G into 1 plus H by R minus 2. It goes up, so plus 2 becomes minus 2. Now how will I use binomial theorem? Just I am bringing this minus 2 here. So G into 1 minus 2H by R. So this is the value of acceleration due to gravity when it is at certain height, but that height is very small when compared to the radius of the earth. Since G dash is equals to G minus 2GH by R, so G dash will be equals to multiply this inside, so G minus 2GH by R. We can write G dash minus G, that is equals to 2GH by R. So G dash minus G will be minus 2GH by R. So what does that mean, minus 2GH by R? It means the decrease in value of G at height. So we can very well see, because of the minus symbol, we can say there will be decrease in acceleration due to gravity at certain height. Okay, so now if we are multiplying mass everywhere, then we are going to get the formula for decrease in weight of the body. Multiply m here, m here, m here. So mg minus mg dash, that is equals to 2 mgh by R. So what is this g minus g dash or mg minus mg dash? So that is nothing but decrease in the value of g at certain height. So this is decrease in the value of weight at certain height. Now what will be the graph between g dash and h? So G dash versus H means variation of acceleration due to gravity with the height. So as the height is increasing, we have seen that the acceleration due to gravity will decrease. So at the surface of the earth it is maximum, then it goes on decreasing with the height.